K-means clustering. Previously, we have explored one category of unsupervised machine learning models, which is dimensionality reduction, PCA, right? Last time we did PCA, which is a dimensionality reduction technique, right? Okay, which is unsupervised, of course. I know. Okay, here we'll move on to another class, unsupervised machine learning model, which is the clustering algorithm. Okay, clustering algorithms seek to learn from the properties of the data and optimal division or discrete labeling of groups of points. Okay, so many clustering algorithms are available in scikit-learn. Okay, so one of them, very simple one, is the k-means, right? So let's talk about what k-means is. Okay, so k-means my keywords. Okay, let me quickly give you an, intuition. Let me fire this up. Right? Okay, so k-means, man, what happens is this. Say, for example, we have some data points. Say, let me pick this one again. So, for example, I have one-dimensional data. Okay. Okay, I have this one-dimensional data, and then there are a bunch of points here. A bunch of points. For example, I have say these 3 points here. For simplicity, I'll just pick 3. Okay, let's not pick too many. Okay, so here I have 3. I mean, you can clearly see there are 3 clusters, right? By eye. Okay, I'm able to see it, everybody. We can say that. We can tell that there are 3 clusters. Okay, so now let's see if the k-means can figure this out. Right? K-meansly, you're going to succeed out then. Right? Clustering, nikalna success out then. Right? So that's what we're going to see. Okay. So let's do this. Okay. When in k-means, we need to, give the algorithm the number of clusters. Right? So here we see that. Okay. There. Okay. We can see that. They're clearly. Okay. Let's see. Yeah, they're clearly here in this case. Okay, so 3 clusters. So we'll just skip 3. Okay, so we give the algorithm that. Okay, there are 3 clusters, right? So let's just call them. Okay, let's rather color code them. Okay, so one can be one is red, another is blue, okay, and another is green. Okay, so RGB, RGB, whatever. Okay, so so what this algorithm does is first make it just randomly assigns these 3 points, randomly assigns these labels to the points to the data. That means, okay, I could pick, for example, I know mainly I can pick this one. Let's see. I'll pick this one as red, or rather, okay, let's make it a little bit. I'll pick this one as red. Sorry, I'm randomly doing it, randomly with that same one. Right? See, and then G, I'll just pick this one. Okay. All right. So I just randomly the algorithm. This is the actual algorithm that's okay. What it does is it randomly picks any 3 points, right? 3 points, and then labels them these 3. Gives these 3 labels, right? Red, blue, and green. Okay. All right. This is the first step, right? So now what we do is, okay, let's keep these numbers, right? Let's keep this number, like number thing right there. So let's see. This is 0.1, 0.2, 0.3, right? And then 0.4, 5, 6, right? 7, 8, and 9, right? Okay. So now what happens is, now what do we do? Is that, okay, for the rest of the points, now we need to label them as well. right? Okay, one of them, they have to take on one of the levels, right? Red, blue, or green. Okay, so what do? Okay, so we basically, measure the distance, right? Measure the distance from that point. For example, 2. Let's start with 2. Let me 2 side. Huh? So what do? From 2, okay, we measure the distance from here to the red point, right? From here to the blue point, and from here to the green point right here, right? So now it's not quite obvious which one is, so is the shorter distance out of these two, right? So we'll assume, we'll make an assumption here, right? So of course there's, it cannot be exactly, same most of the time, right? So now we pick the, the nearest Junsangosani, right? Which way is nearest to red, green, or blue? It will take on that label. Right? So let's say when you look at it, it's more close to red. Okay. Okay, would you agree? Right? More close to red. Okay. So what we do is we just label this red. Okay. So let's keep this. Okay. So these are the centers. So for this is also called the centroid, we can call it centroid, right? So let's label them like this so that we can differentiate the normal point, ordinary points, and then those centroids, eh? Okay. Now, okay, we're done with 2. Okay, let's do the same thing for 4, right? 4 method, right? So in 4, let's see. Let me erase this one. Okay, so here we go. Right now 4. Okay, 4. We did the same thing. Right? We measure the distance from here to the blue centroid. Okay, green centroid, right? And then the red centroid. Okay, so which one do you think is nearest to? Red, blue, or green? Number 4.
Green.
Green, right? Yeah, it looks like, yeah, it's more near green, right? So this is okay. So it does the same thing for the rest of them, right? How about 5? 5 is clearly nearest to
Green.
Green, right? Okay. Okay, very good. Okay, 5 is nearest to green, and then all of these are also nearest to green, right? Okay, so this is the first pass. Okay, all right. Now the next step is, let me erase this one. Okay, now we need to recompute the the centroid, the center, right? Recompute the center. Okay, so let's see. Okay, so let's see. Now, okay, I'm not sure if it'll converge, right? So sometimes it doesn't converge, right? Let's see if it will here. So so then the new center will be this one for red, right? Blue is still this. There's only one point, right? Okay, and for green, it'll be somewhere here, right? So center. Right? We average them. It's average so that we get the center, right? Center of red, center of blue, center of green. Now, okay, so let's see. Now, okay, so the way I chose my random values, randomly selected, so it looks like it may not converge. Let's see. Okay, no, okay, it doesn't quite converge, right? Okay, so so here's the problem. Some problems, right? So let me pick. Okay, let me start over, right? Very soon here, right? So because it didn't converge, it converged by hand. Sometimes it doesn't converge. Okay, so I'll clear this up. Okay, and then let's start over. Okay, so let's see. I'll clear this. Okay, let's start quickly because you have seen how it, at least the first step. So okay, let's see. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so I'll quickly do that, right? Okay, so we have RGB R, B, and G, right? So let's see. I'm gonna pick this one as red. Okay. Let's pick this one as blue, and let's pick this one as green. Okay. So just like before. So as you can see, these 2 points are these are centroids. Okay. And then here we go. Okay. So now clearly these 2 points, let's keep them numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. So okay. So 1 and 2 are clearly now. Okay. There's another problem. 1 second. It converges in the first go. Conversion, which is not also such a good idea. Let's see. Let me try to pick another one. So red, about let's see, green. If I pick green, this one. Let's see. Let's do this green and blue. Okay. So okay. Let's try this one. Okay, here. Okay, so let's see. So clearly you can see that, these two, okay, 1 second. Okay, these are the centroids, right? So let me name them. 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Okay, so let's quickly do them. Okay, so here, these 2 points are red, okay? And then, of course, this is going to be green, right? And then the rest here, it would be blue, right? So far, so good, right? Okay. Now, the next pass is, now we recompute the mean, right? That's where the key means comes from, right? Mean means the center, right? Center. So the red center will be like here. So, okay. And the green center will be around here, okay, and the blue center would be around about here, maybe, right? Okay, so now let's see. So let's see. Now so these are the new centers. Now they're just ordinary points now. Okay, they're just ordinary points. Okay, now we assign membership again, and failure of membership or sign. Right? So now now we again compute the membership. So now will the membership of 1, 2, and 3 change or not based on this new Naya center? Change because still 1 is still nearest red, so 3 is still nearest red. 2 the pilot, and this is center. And when it's 1, 2, 3 change, okay. How about 4? 4 change with that now. Then it's still nearest screen. And 5 penny nearest screen. Okay. How about 6? 6 given.
Green,
yes, because it's okay, nearer to the green, right? Nearer to the green. Okay, so now, okay, this will be green, right? This will be green. Okay, your second pass, okay, all right. And then how about 7, 8, 9? 7, 8, 9 change, which is nearest to blue? Green ki blue. 7, 8, 9.
And the center it's kind of
I say you and this one right here. Blue center blue okay. So okay, so very good. Of course, of okay. Now we still okay. जब समय membership change जस्तै membership change हुँदासम्म it will do that, right? जब membership change हुन छोड्छ, है membership त्यो point of membership जब change हुन छोड्छ, then it will stop, है. Now के हुन्छ भन्दाखेरि now again we recompute the mean, अनि भनेपछि यो mean change हुन्छ, यो mean पनि change हुन्छ, है. Okay, red चाहिँ त अब त्यो change हुँदैन, it's still there, है. Red चाहिँ त्यति नै छ, है. So let's recompute the mean. Hey, there's a green को mean round about here, blue को mean, hey, round about here. Hey, भनेपछि now अब के हुन्छ, अब कुनै membership change भयो यहाँ 1 2 3 4 5 6 7 8 9 membership change हुन्छ कि हुँदैन? हुँदैन है, हुँदैन. Okay, so there's no, because अब हरेक point अब आफ्नो आफ्नो हैन लिइसक्यो जस्तै 1 2 and 3 are closest to this one, 4 5 6 are closest to this, and 7 8 9 are closest to this one, the center. Okay, and then our membership कुनै पनि change भएन नि, now we stop. हैन. So अब हामीले जुन आँखाले देखेको र हामीले पिक गर्दाखेरि त randomly पिक गरे नि त RGB जुन center, हैन. तर maybe in 2 passes, है 2 or 3 passes मा हामीले के भयो भन्दाखेरि see clearly उसले चाहिँ cluster छुट्याइदियो, है. Okay, बुझ्नु भयो so far, more or less. You get the idea?
Yes, sir.
Yeah, okay. All right, so let's go back and then we'll look at this again, right? And this your example of it, you hire two-dimensional videos. Right? So I just ran this standing portal, right? Let's see. Let's create some data right here. Okay, let's so here you can clearly see that there are 4 clusters. Right? Cluster right? We import key means and key means import garçon. We give n clusters equal to 4, right? 4, and this was fit garçon, the standard thing 1 2 3 4, right? 4 steps, right? Import, instantiate, and set hyperparameters, and a fit, and then predict theory, right? So same 4 steps, right? Okay, so we fit x, right? X which is given x means it's supervised or unsupervised?
Unsupervised.
Unsupervised because we didn't give the labels. I'm label the case, right? Labels, right? So we don't give the labels. So if it were supervised, we'd need to give labels as well. Right? Y couldn't import the y side. Okay, and then key means predict also, right? Key means predict. So and then when we plot it, see, plot nicely, see, nice. Okay, very good job. It created a centroid pin so your final, final final centroid data. Right? Okay, so I mean it did a very good job. It did a very good job. Okay, so our isma generally these are called this is expectation maximization. Right? Okay, so expectation maximization is a powerful algorithm that comes up in a variety of contexts within data science. Okay, key means is a particularly simple and easy to understand application of the algorithm. Okay, we'll walk through here. Okay, so so it's a form of expectation maximization, EM algorithm. EM guess some cluster centers. I'm thinking guess some cluster centers. Number 1. Number 2. So you do it iteratively, repeat until conversed. First each step, assign points to the nearest cluster center. Assign points to the nearest cluster center. If you remember, recall. So recall that. We assign points to the nearest cluster center, and then that is the expectation. Maximization. Now after you're done, you set the cluster centers to the mean. Now you recompute the mean. Let the mean life recompute. Let's say randomly we assign these 3 levels RGB. Randomly assign Ani June points or June center ko nazik cha. June center ko nazik cha. त्यसलाई 3 label garyo. Remember? Yes, sir. Okay. And then so after we're done, we recompute the mean of each group, red, blue, and green. Mean take a center. सेन्टर क्याल्कुलेट गर्यौं हैन अनि त्यसपछि हामीले के गर्यौं सेन्टर क्याल्कुलेट गरेपछि फेरि now we assign membership है सो हरेक पोइन्टलाई फेरि हैन membership based on कुनको सबभन्दा क्लोजेस्ट छ हैन so until the membership didn't change हैन isn't that what we did recall है गर्दाखेरि does it make sense हामीले जुन गरे एक्ज्याक्टली त्यही नै होइन है
हजुर सर
so that is expectation so we just use what expectation maximization hey em hey so we'll look at that again and फेरि हेर्छौं but in again one dimension मा गरौँ हामी two dimension मा गर्छौं त्यही कुरा है so let's see where is it okay अब यसलाई है so let me show you that जस्तै यो two dimensional data है two dimensional data मा कसरी हुन्छ है it's the same step यसमा let me take a snip of it okay so snip लिन्छु म okay here we go okay let me take this snip okay very good look at this first make it expectation maximization first step ke thiyo if you do you remember first step
centroid randomly placed
exactly right randomly centroid randomly assigned right so this is step 1 right so let's see okay this is step 1 step 1 ma ke cha hunदै चाहिँ so यो चारवटा we gave 4 हैन चारवटा क्लस्टर भन्दियो उले चाहिँ यो चारवटा के गर्यो चारवटा क्लस्टर सेन्टर so randomly उले सँगसँगै छ तिनीहरु हेर्नुस् त they are close together right okay this is step 1 which is initialization see random initialization of a iterative step right first ma aba yo em1 or em2 em3 right expectation maximization 1 right iteration 1 iteration 2 and expectation maximization iteration 3 okay so अब e step मा के भइराछ भन्दाखेरि okay can you tell के e मा जस्तै यसमा e step मा के भइराछ well step 1 step यो सँग कम्पेयर गर्नुस् step 1 सँग
membership assigned भइराको छ centroid को नजिक जुन छ
exactly thank you yeah email हैन okay very good so yeah okay so see जुनको नजिक जस्तै यो जुन जो त्यही हुन्छ हैन जस्तै all these अलिकति ठुलो बनाउँछु है त so that you can see clearly hopefully okay it freeze fast anyway so look at this understand यो हैन यो सबै पोइन्ट्सहरु ग्रीन को नजिक रहेछ हैन यो पोइन्ट्सहरु सबै ग्रे भनौं ग्रे को नजिक रहेछ यो सबै ब्लू को नजिक रहेछ and so on see यसरी हरेक पोइन्टलाई चाहिँ कुनै न कुनै लेभल चारवटा मात्रै एउटा लेभल दिन्छ जुनको नजिक छ है जुन सेन्टरको नजिक छ त्यो पोइन्ट है त्यही अनुसारको त्यसलाई लेभल दिइन्छ है that is e step by expectation अनि त्यो भइसकेपछि अब नेक्स्ट त्यहाँबाट कहाँ आउँछ भन्दाखेरि it will come here right अब यहाँ आउँदाखेरि ओके यो एकछिन फ्रीज हुन्छ एकछिन यो एप्लिकेसन यो अलिकति प्रब्लम छ त्यसको है okay one second okay यो चाहिँ यो विन्डोज अपडेट गरेको जस्तै I mean it's really giving me problem okay let's try escape I don't know if it worked okay let's see yeah it works now okay so यहाँबाट यहाँ आयो अनि यहाँ आउँदाखेरि अब म्याक्सिमाइजेसनमा के हुन्छ म्याक्सिमाइजेसनमा के भइरहेछ हेर्नुस् त
centroid adjust छ त्यो डाटा पोइन्ट को सेन्टरमा
yeah that's right है अब चाहिँ के हुन्छ भन्दाखेरि अब सेन्टर्स चेन्ज हुन्छ है ओके फेरि रिकम्प्युट गर्नु पर्यो हामीले मीन यो त मीन हो नि है मीनलाई हामी रिकम्प्युट गर्दाखेरि के हुन्छ भन्दा अब यो हेर्नुस् है जस्तै यहाँनेर पुरानो मीन यहाँनेर थियो भने अब यो यहाँ सरेको थियो है ओके अब पुरानो बिन यहाँनिर थियो यो चाहिँ या अब नयाँ मिन यता आयो है पुरानो मिन यहाँनिर थियो सेन्ट्रोइड है सेन्टर अब नयाँ सेन्टर यहाँ बन्यो एन्ड देन पहिलोको खासै चेन्ज भएको छैन है बुझ्नुभयो सो यसै ओके सी दिज आर द न्यू मिन्स जता एरो गइरहेछ नि ओके दोज आर न्यू मिन्स मेक सेन्स ओके अब फेरि बिकज मेम्बरसिप चेन्ज्ड राइट सो अब वी हेभ टु गो थ्रु अब अर्को स्टेपमा पनि सेम इएम है अब यो स्टेपमा फेरि फेरि के दोहोरिने भयो अब के हुने भयो फेरि
फेरि सेन्टरको नजिकमा कुन पर्छ त्यो तिनीहरू डाटा पोइन्टहरू छ त्यसमा असाइनमेन्ट गर्नु
Yes, thank you. That's right. है भनेपछि अब यो त नयाँ है नयाँ सेन्ट्रोइड हो नि त यो त नयाँ चारवटै नयाँ सेन्ट्रोइड हो अब त्यो नयाँ सेन्ट्रोइड हुन्छ नि अब यो मेम्बरसिप अब फेरि असाइन गर्नु पर्यो भन्दाखेरि अघि जुन यहाँ ब्लू खालको थियो त्यो सबै येलो रहेछ नि त होइन अब नयाँमा है सी ओके राइट अनि फेरि हामी त्यहाँबाट के आउँछ म्याक्सिमाइजेसनमा फेरि वी रिकम्प्युट द सेन्टर अब चाहिँ खासै चेन्ज भएन है अलिअलि मात्रै चेन्ज छ यहाँबाट अलिकति यता गएको छ अलिकति थोरै चेन्ज छ है ओके अब यो गर्दाखेरि खासै हामी मेम्बरसिप चेन्ज भएको छैन है मेम्बरसिप खासै अब यहाँबाट यहाँ जाँदाखेरि अब यहाँ मेम्बरसिप यहाँनिर सेन्टर क्यालकुलेट भयो जुन कि म्याक्सिमाइजेसनमा अनि फेरि अर्को स्टेप फेरि यी स्टेपमा वी निड टु रिकम्प्युट आई मिन रिलेभल द पोइन्ट्स बेस्ड अन विच इट इज क्लोजेस्ट टु होइन ओके त्यो गर्दाखेरि खासै हाम्रो मेम्बरसिप चेन्ज भएन यहाँदेखि यहाँ जाँदाखेरि है यहाँदेखि यहाँ जाँदा अनि एम स्टेपमा फेरि रिकम्प्युट गर्दाखेरि अनि सेन्ट्रोइड चेन्ज भएन नि नाउ अब पुग्यो होइन मिन्स इट हेज कन्भर्स्ड है स्टेबलाइज भयो कन्भर्स भयो नाउ दिस इज द फाइनल होइन फाइनल यो चाहिँ ओके ओके लेट्स सी यो यता आएन है सो दिस okay anyway so this is the final one right final one which we see there right? So I mean does it make sense em algorithm बुझ्नुभयो more or less and this is the final clustering as you can see any of the fragment this is the final clustering right so this is how it works how k-means works right okay so let's see अब के means अब यो चाहिँ अब जस्तै के means छ नि यो simple algorithm भएको हुनाले we can write our own function है जस्तै यो अथरले चाहिँ सो यसमा साइकिट लर्न युज नगरिकन यसमा अब साइकिट लर्न युज गरेको छ तर यो डिस्टेन्स है डिस्टेन्सको लागि मात्रै हो है के मिन्सको लागि होइन है त्यो गरेर स्टिल भेरी गुड रिजल्ट यो चाहिँ म्यानुअली गरे बाई ह्यान्ड है विदाउट युजिङ साइकिट लर्नको लाइब्रेरी के मिन्सको लागि लाइब्रेरीमा युज नगरिकन माथि चाहिँ के मिन्स लाग्यो यसमा चाहिँ के मिन्स लगाएर यस्तो आयो होइन यो चाहिँ के मिन्स नलगाइकन बाई ह्यान्ड आफै लेखेर है कोड पनि त्यति धेरै छैन नि हेर्नुहोस् पछि यु क्यान लुक एट द कोड एन्ड ट्राई टु फिगर आउट वाट्स गोइङ अन हामीले जुन गर्यो त्यसैलाई हामीले कोडमा राख्यो उनीहरूले चाहिँ अथरले कोडमा राख्यो है एन्ड स्टिल इट गिभ्स अ भेरी गुड रिजल्ट सी ओके सो इट्स अ भेरी सिम्पल algorithm है relatively simple algorithm right? Okay so then here we have you know caveats means warning just okay so key what could go wrong right using यो भयो अनि त्यसपछि so okay all right so rest saying I mean it's these are examples so main कुरा चाहिँ I wanted to show you give you this overview okay what k means is all about right baki say you can figure it out on your own right tapaile afai you because we have done so much of it right so much of code and everything so tapaile afai bujhnu saknu parcha right okay so all right that's all that I wanted to cover right okay so any questions let me take a snip
स्टार्टिङमा क्लस्टर कतिवटा चाहिँ छ भनेर कसरी डिसाइड गर्नुहुन्छ भन्ने लाइक यसमा के छ त सुरुमै दिनुपर्छ नि त नम्बर अफ क्लस्टर भनेर त्यो कुरा चाहिँ लाइक अब त्यो इडिए गरेर गर्दाखेरि चाहिँ त्यसरी थाहा पाउने हो कि चाहिँ कसरी
yeah very good question very good question त्यसको लागि okay let me see 1 second let me take a snip first before I forget see okay okay all right यसमा कस्तो हुन्छ भन्दाखेरि yeah that's a good question किनभने हामीलाई त पहिले थाहा हुँदैन कति क्लस्टर छ हैन त्यसमा के हुन्छ भन्दाखेरि हामीले त्यसको एउटा टेक्निक छ कि त्यसमा हामी के गर्छौँ भन्दाखेरि त्यसको त्यो भेरिएन्स कति छ त्यसको होइन यो भेरिएन्स हेर्दै जान्छौँ कि जस्तै यसमा जस्तै हामीले जस्तै क्लस्टर जस्तै 2 बाट स्टार्ट गरौँ न होइन क्लस्टर 2 बाट स्टार्ट गरौँ त्यसको त्यो ओभरअल भेरिएन्स कति छ त्यो जोड्ने कि है अनि सेकेन्ड स्टेपमा है अनि त्यो भेरिएन्स के घट्छ कि बढ्छ कि है नर्मली घट्ने होइन घट्ने अथवा बढ्ने हुन्छ होइन अनि त्यो टोटल ओभरअल भेरिएन्स जस्तै होइन यसको भेरिएन्स चाहिँ होइन यहाँ यति भयो होइन त्यो भेरिएन्स जोडिँदै जाँदाखेरि टोटल भेरिएन्स होइन अनि के हुन्छ भन्दाखेरि त्यसलाई चाहिँ हामी ग्राफ गर्नुपर्छ है जस्तै 2 क्लस्टरमा कति टोटल भेरिएन्स कति आयो है रेडको भेरिएन्स ग्रिनको भेरिएन्स ब्लूको भेरिएन्स तिनटै जोडिन्छ है कति आयो है अनि त्यसपछि त्यसमा हामी के गर्छौँ भन्दाखेरि त्यसलाई बढाउँछौँ अलिकति है सो मेबी 3 है क्लस्टर 3 मा जाउँ क्लस्टर 3 गऱ्यो भने चाहिँ अब त्यो बढ्यो कि घट्यो होइन त्यसरी त्यो हामी त्यो ट्र्याक गर्छौँ कि त्यो भेरिएन्स बढाएको चाहिँ घटाएको छ अनि त्यसलाई चाहिँ हामी के गर्छौँ भन्दाखेरि हामीले चाहिँ त्यसलाई चाहिँ ग्राफ गर्छौँ है यसरी ग्राफ गर्दाखेरि चाहिँ होइन त्यो भेरिएन्स जस्तै समथिङ लाइक यस्तो खालको हुन्छ होइन गर्दाखेरि यहाँनिर एकदम सर्ट एल्बो जानेर आउँछ है त्यहाँनिर द्याट इज योर आइडियल है आइडियल क्लस्टर नम्बर है सो there is a technique for that. There's a very nice YouTube video. म तपाईहरुलाई त्यो भिडियो शेयर गर्छु है so you can watch that video. Very simple. एकदम राम्रो तरिका एक्सप्लेन गरेछ है so I'll send you that video है okay so त्यसमा यो सबै कुरा पनि एक्सप्लेन गरेको छ प्लस कसरी त्यो आइडियल क्लस्टर सेन्टर है how to arrive at that है त्यो पनि एक्सप्लेन गरेको छ है so I'll send you that video है अरु के क्वेशन्स all right so very good so as okay so that's it eh? That's all so I expect everyone to do their homework eh? So homework चाहिँ गर्नु पर्यो हैन let me stop the recording